When we examined the Type A sample last year under the scanning electron microscope, we got some pretty amazing results. The beam of electrons the device emits to analyze the object appeared to make holes open on the sample surface. Let's turn it off to see if it goes back to normal. And even more crazy, the holes looked like they closed up after we shut the electron beam off.
Look at that. This stuff is fixing itself.
Yes, it's healing. That's exactly right. We want to see if that'll happen again.
Are we set to go?
Yeah.
All right, so.
Okay.
All right, so let's turn on our beam, get a big picture view really quick. Okay.
The responsible thing to do is to repeat the exercise in the scanning electron microscope on this Type A ceramic-like material. That will allow us to confirm whether or not the beam really is making topological changes or if it was just an instrument artifact in the machine.
There we go.
I can see the cross-hatching.
Yeah.
Look at that.
Zoom in here.
All right. You can tell you got charging already.
Yeah.
Okay, now notice also the difference. Already you're seeing it takes on a very porous appearance quickly.
Yeah. This is all effects we saw last year.
Yep. This just validates that we're getting exactly the same behavior qualitatively.
Yeah.
Okay.
I'm seeing the same contrast changes that we saw last year. Consistency is good. And I'm more convinced than ever that we are seeing significant effects of the electron beam on the surface.
All right. Should we move on?
Yes, let's move on to the Type B sample.
Yeah.
Now, a really interesting question is whether the Type B material would be comparable to the Type A changes that we saw last year.
It's a little dark.
Yeah. You know what I'm not seeing yet? I'm not seeing any of those conspicuous sort of openings.
Yeah. It doesn't seem to be changing. Clearly, they are different materials.
Right. Maybe they're from two different buried objects.
Clearly, they are different materials. So this is the first sample surface.
Maybe they're from two different buried objects.
The two look very distinct.
Yeah, I agree.
The behavior of this Type B ceramic under SEM analysis is quite different than the Type A ceramic. We're not seeing any of the changes that we might have expected to see based on our previous results. I think it's pretty clear we're dealing with materials that are completely different. But what are they doing inside of the mesa?
So this is one we might look at elemental analysis on.
Yeah, we can do that right now.
Yeah. Let's start with the Type B.
Sure. We're going to take a spectrum of the elements that are on the surface.
Okay.
It's one thing to see the physical differences in these materials, but we need the elemental analysis of this stuff to make sure they truly are different from one another.
Okay, so we're starting to see there is some oxygen, quite a bit of calcium, some phosphorus, and then trace amounts of silicon, aluminum, iron, sulfur, potassium, and all these things that are present in the Earth's crust.
Okay.
Well, this isn't the answer we hoped for, but it might give us the bottom line on Type B. These are the exact elements that make up the Earth's crust. So Type B was likely made from materials that naturally occur in the mesa. But what about Type A? We still don't know who made it or how they made it.
Can we compare that to the composition of the Type A sample?
Yeah. Zoom in here. Okay. There is a stronger magnesium, but it's multiple times higher.
Okay.
And a lot more aluminum than iron.
Yeah. Far less calcium. They're significantly different from each other.
Okay.
This just makes me more convinced that we're looking at engineered materials with Type A.
Right.
I think the most important takeaway from all the Type A materials we found in the mesa is that they were likely manufactured by someone. But who and for what purpose?